So in this question, I'm told that Mary needs to work out the size of angle X in this diagram. So we have the triangle here, triangle ABC, and we have angle X here. And then we have this angle, so ABC, the angle ABC, is 63 degrees. And then we're told that she writes X is equal to 63 because base angles of an isosceles triangle are equal. Mary is wrong, and we're asked to explain why she's wrong here. So this question is worth 1 mark, so we're just going to be looking to state a short reason as to why she is incorrect. Now if we look at this triangle, these little lines here show that these sides, AC and BC, are equal. So they're equal in length. So for an isosceles triangle, this is going to be an isosceles triangle because we have these two sides which are equal in length. And for an isosceles triangle, the reasoning here is correct. The base angles of an isosceles triangle are going to be equal. However here, angle X is not going to be equal to 63 because if we were to have a triangle like so, and these two lengths are equal, the base angles here are going to be these two angles. Now this triangle that we're working with is kind of rotated here. So in actual fact, the base angles of this triangle are going to be this angle and this angle here, which are going to both be equal and they're going to be 63 degrees. However, this angle here, the angle X, is kind of the top angle in this diagram. It's not one of the base angles because it's between the two sides that are of the same length. So angle ACB is not going to be equal to 63, so X doesn't equal 63, and that is because X is not a base angle. Alternatively here, we could have gotten the mark for working out what X would be. So if angles in a triangle sum to 180, we can subtract 63 and subtract 63 again, so both of the base angles, to leave us with X, which is going to be equal to 54 degrees, and we could have stated that to get the mark here. So now here we're told that William needs to work out the size of angle Y in this diagram. So we have the two parallel lines, so that's what these little arrows mean. DE is parallel to FH here. And then we have this line from E to G between the two parallel lines. And we have an angle of 57 here and an angle of Y here, which is what we're looking to find. We're told that William writes the following. So his workings that angle EGH, which is this angle here, so this angle here, is equal to 57. And the reasoning is because corresponding angles are equal here. And we then have the working that Y is equal to 180 minus 57 because angles on a straight line add up to 180. So they've taken this angle EGH and subtracted it from 180 to be left with Y. And we're told that one of William's reasons is wrong, and we're asked to write down the correct reasoning here. Now if we look at his reasons again, angles on a straight line do add up to 180, and this makes sense because if this whole angle here is 180, we subtract this part, we're going to get Y. However, the problem here lies with the fact that angle EGH is equal to 57 because corresponding angles are equal. Angle EGH is going to be equal to 57, but the word corresponding here is incorrect. So corresponding angles I remember as F angles. So for example, if we had two parallel lines, then corresponding angles would be this angle here and this angle here. They kind of make an F shape. Whereas the angle in question in the question, we're working with an angle like this, and it kind of makes a Z shape in this instance. So we're working across here, and we're making a Z shape. And the Z shape angles, I remember sometimes to do with A to Z, that kind of thing, A and Z being kind of next to each other, that the name for this is alternate angles. So to get the mark here, I'm simply going to write down that alternate angles are equal. In this instance, because we're working with alternate angles in the diagram.